And that's kind of what I did with this. I got some connectors and I had to have some more, but I went and got some pipe, at the big box store and came down and just started whacking it in pieces and putting it together.
Well, yeah, great to meet you, Delen,
Nice to meet you.
and thanks for getting on the call. I really appreciate you spending the time. I think um, the build that you did about the solar panel uh, rig and mount um, is really cool, and you incorporated so many different things into that and things I've never seen before.
Really?
Yeah. Oh, yeah. There's so much from and we'll get into it, but the sliding clamps and
Right.
just all those different kinds of things really were really cool and something I hadn't seen before. So, way to go. Nice job.
Well, I started out, looking for some hardware to do something like that with because I had a picture in my mind what I wanted to accomplish. And of course, I went to the big box store and I looked at the parts that were available and kind of deciding what I could and couldn't use. And then I looked online, and actually, I think it was an advertisement, a maker pipe that popped up somewhere in there. I don't recall exactly how I got to it, but I never heard of it before. And so I actually exchanged a couple of emails with you early on. You probably don't recall those now, but I'd asked a couple of questions. And so I ordered a very small order because I'd never seen them and I want to see what they look like just to play with them a little bit. So my project took three separate orders basically because upfront ordered just like a couple of each of the parts to see how they work and how they fit together. Then I ordered an assortment that I thought would do the project, and then I needed like just three or four more at the end, and I had another small order at the thing. So it kind of spread out. The build itself did simply because I just didn't have all the parts. But it's a fairly simple design from the standpoint of how many pieces are there and the length of the pipe used. But I wanted something that met a specific criteria. I wanted something that was light. I wanted something that would hold the solar panels, flat. I studied up on solar panels, and depending on the different time of the year, they have to point in a different direction relative to the sun. In the summertime, they're almost flat on the ground in my latitude, and in the wintertime, they'll be up really, really steep. So to have something flat that could hang on the garage wall and that met those criteria, I had to have uh, parts that would move. And so that kind of what led me to, I did a couple of my own homegrown fittings, if you will, just to make that happen.
Yeah, and it can you explain just where the project came from, the idea for the project, what you needed?
So we had a tornado that came through North Alabama a number of years ago, and the top third of the state was out power with like a week. And my wife and I, that's not the first time that's happened. We've had tornadoes, whatever, when we lived other places and been without a power for 3 or 4 days or up to a week. Then you kind of throw in the pandemic, and we bought a boatload of groceries to fill up the pantry, and we filled up the freezer and all that. And my wife says, this is all well and good, but if we have one of these freak tornadoes that come through and knocks out the power, all that stuff in the freezer is going to ruin.
Yeah.
So I thought, well, why don't we get a generator or something? We talked about that. A generator, you have to have gas for, and if you never use the generator, the gas goes bad. It makes noise. It has fumes. You have to put it somewhere, etc. So I thought, solar would be neat, and I've always wanted one of those sort of things. So the bottom line with solar is your capacity may be more limited than like a gas generator. So you have to kind of decide what it is that you want to power with it. So I sort of did a big study on the solar power opportunities, and I figured out quickly that I didn't want a whole house solar power. I wanted some off grid solar power because what I primarily wanted to do was run my refrigerator and my freezer for say 2 or 3 days, and maybe be able to run lights and stuff like that in the evening, coffee pot for a few minutes in the morning, that sort of thing. So what I did was I bought a watt meter, and I went around and plugged this watt meter into the different appliances that I wanted to run with my solar power. And I let it run for, 3 hours, and I determined how many watts those things were consuming. So that told me I could build a budget of power that I needed. And so I knew that I needed something that had the output of a regular wall outlet. So initially, I looked at sort of an RV style system where you have a separate inverter, a separate charger, so you can keep the batteries charged, big acid, lead acid or lithium batteries, etc. And that would be kind of bulky. It'd weigh like 350 pounds. I'd put it in some kind of cart that would be sitting out there in the way in the garage to have those big batteries and all that sort of stuff. So in the end, looking not only with, I had to have a certain amount of power, but it's power that I hope will very rarely be used. I decided on a self-contained unit solar battery. So that solar battery already has the inverter built into it. It's got a charger built into it. It's got the connections for a solar power panel in it, and it has lithium batteries in it. So the one I have now will put out, enough wattage to run my freezer, enough wattage to run my refrigerator. The capacity limitation is the watt hours that the battery holds. If I start out with what will run for a day, and if I can supplement that with solar power panels, to run a little longer.
Mhm.
So basically, with the solar power panel I have produces 400 watts optimum, and so the capacity of my unit should last me a day and a half to 2.5 days just running my freezer. My intent is to buy a second battery unit so that I can have one for both the freezer and the refrigerator. So that was kind of the need, and then kind of how I got to what I wanted to build. And initially, I was thinking 800, 1200, 1600 watts of solar power. And if I did that much, I don't have a place. We have like it's a garden style home, and with our covenants would allow us to put solar power panels out in the yard all the time and that sort of thing. The 1600 watts of power would be wonderful, and I could power more things. But if I'm only thinking about, I'm happy to sit around with one light bulb in the evening and have frozen food in the freezer and be able to cook on the grill, I needed something more compact. So it came down to this. It conveniently hangs on the wall on some hooks, and I actually have room for a second one to hang on the wall. But
Yeah,
I'm not using.
I'll bring it up in a second, so everybody can feast their eyes on it. But I think it's really interesting the way you went about engineering the system, because, and that's something that I've looked into recently myself. We got a van that we want to put a solar system onto, and the
Right.
first question is, how big do you make the system? Right? How much power are you going to consume? How long do you want it to go for? Because at that point you're really engineering something. You're not just buying the biggest thing you can afford, you're fitting it to what your needs are. So seeing that watt meter is really interesting to me, because you can actually get some data, know what your power you are going to be consuming, and then design the system from
Just want
there.
to go
And
with it. And
that's very
I
smart.
wrote I wrote this sort of stuff up in a document that I actually could email to you if you want to read over it and see if it helps. One of the things I learned early on is that if you have a small four cubic foot freezer, for instance, and it says it requires 53 watts of power, I bought a small solar power bank that could easily run that 53 watts. Well, when the compressor comes on, the compressor takes um, 5 to 10 times that 53 watts to get going.
Mm,
Now, I think some RV style units have capacitors built in that kind of slow starts it so
mhm.
that you don't have to have that big, huge drain. So I started out with a solar power before I bought the solar panels, go with the solar power battery that wouldn't run what I had because the inverter capacity wasn't great enough.
Mm,
So I guess the bottom line is your inverter capacity needs to be as good as a wall plug if you're going to use it for many, many things. So
mm.
your watts that you produce are the amperage times the voltage. And so if you have 1500, 1800 watt, wall plug, that's kind of how you get there on 12 volts. The other thing to be really aware of is since you're trying to produce a certain level of wattage, the higher the voltage, the lower the amps. And the amps are what create the heat in the wires. So if you look at some RV style installations, you may have to have, zero alt cabling to run between it if you run it at 12 volts. So people are going to 24 volts even, or 48 volts, so that the amperage is lower and you can get longer cable runs with smaller cable, and that really helps your cost. So the amperage that you need, it's best to keep that as low as possible.
Mm.
In my particular situation, I have four panels that are 12-volt panels. They're wired in either series or parallel, but I put two in series to make 24 volts, and then two 24 volts groups together to have the whole thing be at 24 volts.
Right. So
And in my
series
case,
for
that
two
was
and
determined.
then parallel for those two sets. Is
Right.
that right?
That's right.
Okay.
And in my case, the application of it was dependent on the requirements of this little solar power bank that I used. That
Mm.
I put their recommendation to get the maximum panels that they could accept,
Hmm.
and it works good. I haven't
What?
gotten 400 watts yet, but in winter sun, I got 390 one day. So, it's
Wow.
pretty.
Yeah, that's fantastic. And I would love to put that information and make that available to anyone that might see this, because designing that system is a challenge for sure.
There's a lot of stuff out there on the web. I'll send it to you. Maybe you can look at it and see if you think it'd be appropriate for wide distribution.
Yeah. Yeah. I think the voltage battery is interesting too, right? I've seen where 12 volts is the standard, and then 24 volts, like you're explaining, is something that's uh, becoming more common, and then also reduces the amperage over the
Right.
system. And like you were
Right.
explaining, what's the trade-off that you found? You went with a 12 volt system, right?
Well, actually, it's a 24 volt system.
Okay, so you did go
I've got a
24.
24 volt, using a 24 volt system. The system that I have really is geared more toward this, retail power bank. It's all inclusive.
Mm,
Um, so it's the Echo 1300, I think was the name of it, but I can send you the name as well. So if I were doing a separate system where I were doing lead acid batteries, I would use golf batteries. And the benefit of using uh, I would actually use not 12-volt batteries, but 6-volt batteries, because the number of cells in a given size battery, they're fewer and larger.
hmm
So if I were going to do it with in an RV style, something like that, I would use the 6-volt golf batteries, have four of them, wire them up to produce 24 volts.
hmm
Of course, I'm not an expert on this. There are a lot of people out there that really know this stuff. You're asking what an accountant, retired accountant, figured out from studying this stuff on the web. But if I were going to build a separate standalone RV style system, I would go with, of course, if you can afford it, you can buy um, the big lithium batteries, which cost multiples, two or three times as much.
Sure.
Um, one trade off in some of that is cycle time and how long the batteries last. So there's a lot of little nuances of it, depending on how you're going to use it, that might make one more economical than the other. I studied on a $4,000, $3,900 system, um, RV style, would had more capacity, but it was going to be heavy and in the way, versus an $1,800 or $1,500, whatever it turned out spending $1,500 system that was compact and met my minimum needs. And so that's how I got to it. If I were going to be operating in the van situation, in my mind, you want solar power panels that are always there, but if you think about it, you have to be careful what you put on your solar panels, and that creates some difficulty or problem. If you're going to be camping out where you want to power a whole lot of stuff, um, a design like I have, where you've got double panels and they fold over, and there's a grid on the back, and you can put stuff on top of it. But as you get the stuff off, then you open it up, and you've got 800 watts or whatever of panels on top of your vehicle. You can go out in the middle of the desert and just stay full time.
Mm,
Um, the offset to that is, you really can't run heat very well from solar panels. That's where I think a diesel heater, or what most of these like spirit vans and people use, they have a heater that runs off the diesel, that it's the tank and runs the engine. That's a lot more effective from a heat standpoint,
mm.
or maybe wood pellet or whatever. But it runs things well that certainly that don't have big motors in them. But if you want to run your radial arm saw, it takes a big Kahuna solar power battery.
Yeah, yeah, but you might have an accountant background in accounting, but I can tell you've done your research and you're well spoken about it. So we'll leave that, and I appreciate the
Okay.
information because you set off to do a specific thing, right? Your goal was to provide emergency power so your groceries that you spent so much money didn't go
Right.
bad,
Right.
right?
For a limited period of time,
For
hopefully.
a limited period of time. Yeah. So, and that's where the engineering comes into play because you can get this huge honking system that weighs a ton, but you set off with a specific goal. And
Buy
it looked like,
self-contained units. You can also buy self-contained units that'll run a small cabin, but you're talking about $5,000 or $7,000 to buy those.
sure, sure. Yeah. So it seems like you've accomplished your goal, at least from what you posted. So if you don't
Yeah,
mind, let me
sure.
bring up some photos, or would you like to share?
You go ahead. Go ahead.
Okay.
I think I have the same photos, but go ahead.
Yeah, thank you for posting it on the Maker Pipe community. Can you see that photo?
I can. That was my first day trial.
Oh, nice.
Uh,
But there's the panel in general, right?
right.
Um, and maybe just walk us through some of the bullet points about the what you built.
Okay. So I wanted something that would be flat, so you can see that the stabilizing bar that comes up here on the far right. I wanted that to slide up and down, and of course that kind of creates an arc. So if that slides up and down and changes the orientation of where the pipe is, I had to have a swivel at the bottom. Now I
Hmm.
think you're working on a swivel connector, but I haven't seen it offered for sale yet. So I made my own. Um, Also, I'm using half-inch pipe, and the only difference between this version and my final was I came back and took off the top pipe, which was half-inch, and replaced it with 3/4. I had just a little bit of sag because of the weight of the panels. Now, these panels are very light. There's no frame on them. They're really good for boats or RVs. If you have like a slightly curved surface or something like that, you can
Oh,
actually uh, you could put screws through them into the top of like let's have a boat canopy or something. But I use those. They weigh about 5 or 7 pounds a piece. So this whole unit together weighed about 42 pounds, even with the larger bar. I didn't want to have torsion, so I wanted parts that moved and parts that wouldn't. So obviously, it's easy with uh, the nylon bushings to let that slide up and down, like I've got there on the top corner, the black T connector. It
hmm.
slides up and down because it's naturally going to do that. I've found if you don't go to real extremes to make it not, because it's got the nylon bushing in there, so you can tighten everything well enough it stays in place, but it still slides a little bit. But I want to stop it at a certain angle, so I basically used the off the shelf um, conduit connectors. Um, so this is one. I used this one, and I didn't send a picture of it. They make them that are a hard metal, and then they make these soft cast metal ones. The hard metal ones are the ones that I cut in half, and I use those. If you enlarge the picture of that first picture, you would see that it won't slide up and down. Um,
Right here.
Right. If you double clicked right there, you'll see at the very top of the pipe,
Right.
you see there's a little round thing right there. That is basically a conduit connector sawed in half. And if you double click on the picture, will it enlarge it?
It unfortunately it won't. I can't zoom
Okay,
in.
can't zoom. But that's what that is. I put those connectors on there so I don't have to worry about it pulling it up and it
Mm.
popping off and coming apart. And then I've got one down the bottom side that limits how far down it can go. And those I just loosen up when I want to collapse it down. Okay, then the next point down at the bottom, as the
Is
pipe,
it similar? Excuse me,
it's
Dean.
very
Is it
similar.
similar to
It's
this?
it is. It's just like that. Does the same purpose, but instead of being a soft cast fitting like that,
Right.
it's it's just a hard fitting. It's real hard, and it's made for the same purpose. You put two pipe together, and it's got two set screws. I
Yeah.
just it's a little indentation in the middle. So
Okay.
I just
Yeah,
put
I'm
those in.
familiar with that. This is the soft cast metal, and the other one I think is formed from, sheet steel or something like
Right,
that.
right.
And you can get that. Neat. Okay.
So that got me something that slides up and down with a stop. And as I said, as you slide that down, the angle of the pipe changes. So I needed an angle at the bottom. So
Hmm.
I basically just put them on top of a big piece of metal with a 2 pound sledgehammer and flattened them, drilled them, and then I put a sheet a stainless steel screw in there so that it would articulate back and forth. And then when I want to collapse it, I pull it totally out, the front of the solar panel totally out, lay this down flat with a frame, fold it up, and then I hang it upside down on the wall. I also wanted the to
I'm
have a
trying to.
rotation.
There's one.
Yeah, there
Okay.
it is. It's conveniently hanging on the wall. I turned it backwards so that if something comes and hits that, it won't hit the solar power panels, etc.
So
Um,
smart.
you can see that it's going to be very rigid this way, and then to keep it from having any kind of torsion that way, all of the corners and places that aren't supposed to move, I actually used E6000 glue, and I glued the corners so that I made them very rigid. I found that no matter how much I tighten, since I'm using the 1/2 inch with the nylon bushings, it has a tendency to have a little more give in it than the using 3/4 everywhere.
Uh-huh.
And so I use that E6000 glue, and that basically locks it in. So
Oh, wow.
in this case, where you're seeing the horizontal pipe coming into the T connector, that would be glued, and then you can see those little connectors I put on the bottom pipe that's going away from you. That keeps it from going back and forth, but then enables it to turn. So it's at an angle right now like that, but it'll fold flat. That's why it's sticking out. So that'll go flat, and then it's got to be about this far at the top because of the T connector, the rotating connector I made.
Hmm.
But that's it is. I've historically built things out of wood, and so the way I do that is I have an idea, I go get some wood, and I just get started. And that's kind of what I do with this. I got some connectors, and I had to have some more, but I went and got some pipe, at the big box store, and came down and just started whacking it in pieces and putting it together. But I started with the fact I needed a big flat surface for those solar power panels, which I put on with big zip ties.
Boy.
Keep the weight down, and so it works well. And I'm looking for another project now.
Well, I try to get people to build one thing out of maker pipe, and then usually it follows with other things.
Yeah. Well, this is basically Tinker Toys for big boys, and
Tinker toys for big boys. I like it.
yeah, yeah.
Yeah, that's fantastic. I mean, from the glue and then these stops that you made out of the conduit couplers is what I call them. But yeah,
Right, right, right.
and then everything how it folds together. I mean, what a great job, and a lot of thought went
Thanks.
into it.
Probably more tinkering than thought. But
Well, I mean, I'm glad you found it iterative and you could change it and adapt it, and that our
right.
our product fit that, because that's part of it. I'd like to have that.
Yeah,
Um, but yeah, and you can see the panels from this angle how thin they are, and
they
that they
are.
just have these grommets, and that they're flexible, so you can really put them on any surface. That's neat.
If I were going to use it outside fully on the ground all the time, I very likely might use, maker pipe in that installation as well. I would probably use those hanger rods for conduit. You've seen those.
Hmm.
It's got a metal form that you can use that because they're more rigid and add strength to it. And I'd probably use power panels that have the frame around them. For the same price, I mean, you can buy one that's got a frame around it. These are very efficient. They're very modern, and so it's this seemed like the best choice all the way around to accomplish what I needed to do.
Hmm. And then, so those panels will just plug into your all-in-one inverter, charger, battery bank,
That's right.
and that's all you've got.
That's right. That's it. And so the inverter plugs into the solar power panel. It will also, of course, plug into the wall when the power is not off, and then that inverter, which is only about this big, um, it runs a refrigerator, it runs a freezer. You just plug it in with a long cable,
Wow.
long power cord. Yeah.
Yeah. That's amazing because I have to say I found myself in that exact situation as well. I early last year I bought all this food, and then that first time that the lights flicker and you didn't really think it through,
Right.
that gave you some concern. So
Right. Right.
I think a lot of people can appreciate this situation. I mean, where it's winter or
Right.
tornadoes, loss of power for a temporary period of time. That's fantastic.
So those solar power panels are pretty tough. It's not like they're you have to be very, very, very careful with them. And the connection to the maker pipe is so much easier since they're flat. They've got grommeted holes in them, and you can just use the zip ties. If you use standard ones, they got this metal clip things and all that sort of stuff. And I have to attach those, rectangular square metal clips to the
Mhm.
round pipe and all that, and it would add cost and added weight. And so the zip ties really, with that design, was a big part of getting the weight down and all that.
Yeah, that's neat. After seeing your build, I thought, boy, that's something that I'd like to have around the house, as well.
You need
So
one, definitely, definitely.
absolutely. And yeah, if you wouldn't mind sharing the components that you used, I'll
Okay.
make those available. Take a look at them because people's needs might change, right?
Right,
But at
right,
least
right,
they have
right,
a to go off of all the research that you did, and
right.
it turned out successful, right? You happy with
Yeah.
the solution?
I am very happy with it. I just need another solar power bank and probably another panel array. Um, and the next go around the panel array, I may not do four like this. They make a solar power panel that's like 320 watts a single panel. And
Hmm.
if I did that, the geometry and all of it could be simpler. It could actually look like a painting easel, if you will, almost,
Hmm.
rather than having something like this. But if you think about it, if you put it out there and the wind's blowing 15 or 20 miles an hour, with this, one of the things I can do is I can set some, firewood or concrete block or something on these bottom railings so that it'll be rigid and won't move. So for a lot of reasons, the tripod concept didn't seem like a good concept
Hmm.
unless you have a way to weight it.
Right, right. But you've got that bottom structure to put things down, and you
Set it
know,
up.
it's probably a situation where you're going to take care. I mean, the power's out. It's going to be in the front of your mind. So moving it a little bit, adjusting it, weighing it down, not a big deal at all.
No. And to get the maximum efficiency, of course, you have to move it because the sun's over here in the morning and the sun's over there in the afternoon. If you have a big commercial or a full house, you put enough panels so that even though they're not getting optimum efficiency, perpendicular to the sun, on average, they get you the power you need. If you want an off grid, you want that thing, pointed exactly the right way because it makes, 10 or 15 watts an hour difference. So maybe over 6 hours, you get an extra 100 watts. Well,
Mm,
that'll run your freezer for, an hour and a half.
yeah, that's great. So have you had to put it to the test? Has it been deployed yet?
No, I've played with it and I've run things on it just to see. I haven't run my big saw yet. I think it would kill this solar power battery that I have. It would shut it down. Um, so I'm looking to buy that second one that's a little bit larger than my current system. My current system will run the big refrigerator freezer. It's in double doors, but for at least a day. But the power tools is the things it will not. And of course, it would be really convenient to go if you're going to build a cabin in the woods to have your portable solar power panel and your solar power battery and use your power tools and build you a cabin. So that's a kind of an off-grid thing. The one thing that I did also do is I bought a meter that's intended to monitor the output of a solar power panel, and I put that meter in a little box, and I could send you a picture of that. But I put that meter in a little storage box with solar cable connectors coming out of it, and I can connect that between the solar power panel and the solar bank.
Mm.
Most solar power batteries have a watt meter that shows, or the better ones do, that show the solar power output. But I put this in as something I can connect, and it helps me aim the solar power panel and also test for things like voltage. When I first started with the first solar power bank, it had a different voltage, and it just had them reversed. Its connectors were reversed versus this last one I bought. And so I started out with a solar power panel that would work. I bought a nice new solar power bank, and it wouldn't work. But that gauge that I put in there quickly told me what my problem was. So it's kind of a fault thing, and I'll send you a picture of that. I don't think I posted that picture. It's just something. It's kind of a homemade thing, but I bought a $15 solar power monitoring battery, power monitoring meter off the web, and made that little tool out of it, and that really helped with getting it connected.
Yeah, I could see where that's really helpful in finding the right angle and position to get the max out of your solar panels. Neat.
And also, is it putting as a solar power, as a solar panel array putting out any power, even though it's not getting to your um, your solar bank? Is that because the wire that they provided and you had to change connectors on it's so small that it's not making good connection or whatever?
Oh,
I mean,
yeah.
I found it was a good going from a very small solar power bank, which was a certain degree of ruggedness and build, to a more useful industrial almost quality. I saw a lot of differences, so it's just kind of a good fault finder. It's like a voltmeter.
Mm. Yeah. Yeah.
That's all.
Well, that's fantastic. Even though it hasn't been deployed yet, I
It
hope you don't have
works.
to use it. You
I
know
hope
it
not either.
works, right? But I hope you don't have to use it, and it just brings you peace of mind for your fridge and freezer.
Very good. Very good. My wife's happy with it. Yeah.
There you go.
Yeah.
Well, great. Well, thanks so much, Dee. I truly appreciate. I've learned a lot, and I appreciate you jumping on a call with us. Thank you so much
Certainly.
for your business and your orders, and also
Pleasure.
sharing your project too. A lot of people like that.
Thank you very much.
All
Have
right.
a good day.
All right. Talk to you soon.
All right. Bye.